Okay, so now that we've kind of gone over what happens at each zero, depending on the multiplicity or the exponent of that expression, we can kind of start piecing together a graph. If I give it to you, you can write me the equation of the graph. Or if I give you the equation with different multiplicities, you can kind of sketch what we think the graph might look like. So one thing that you want to remember is from last Friday when we did our original graphing, we had rules for like even, odd, negative, positive type functions. So you just want to remember that, uh, even degree, positive leading coefficients will kind of look something like that, right? It's like almost like a W that opens up. Even degree negative leading coefficients will always kind of open down, okay? And odd degree, but a positive leading coefficient rises from left to right, and an odd degree negative leading coefficient will fall from left to right. So we still need to remember those patterns because we need to decide, like when we're writing our equation, should I put a negative or positive number out front? And when you're graphing it, like where should I start and stop my graph? So you need to definitely still remember those 4 rules for graphing functions. So in 1, 2, and 3, all I want to do is write the equation. And if you noticed, I am asking you to write it in factored form, or the factorization of it. So what you're going to do is identify the zeros, and we're going to put them back into their expressions, and we're going to use the correct exponent based on what's happening at the zero. So for example, if my zero here, the first one's at -3, then inside the parentheses, that would have been an x to the third. Because it's passing straight through, we know from our notes on the front, anything passing straight through means the exponent must have been just a 1. So I'm going to leave that as x plus 3. The next zero goes through at 1. So in the expression, that must have looked like x minus 1. And again, that's passing straight through, so my exponent is just 1. And the last zero is going through at 4, so that would have looked like x minus 4. And again, it's passing straight through. It's not really doing anything else at the 0, so that exponent would have also been 1. I am going to look at the shape of this graph. It is rising from left to right. So because it's rising, it's kind of following this pattern right here. So I'm going to make sure that the number out front's positive. So I can just leave it like this, and it's now positive leading coefficient. And if you think about it, if that's an exponent of 1, 1, and 1, if you add the exponents here, 1 plus 1 plus 1, that's a degree 3. So that is an odd degree with a leading coefficient of 1, or positive number. Moving on to the second graph, y equals, I'm going to start with my first zero, which is at -2. So in the parentheses, that would have looked like x plus 2. Now it's just touching and bouncing back off. So based on the front page of notes, that must have meant that your exponent here was 2. This is a multiplicity of 2 if it's just touching it and going back off. If I move over here to the next zero, that looks like it's going through at 1. So in my parentheses, that would have looked like x minus 1. And that's just passing straight through. So I'm going to leave that as just x minus 1. The exponent or multiplicity would have been 1 here. And over here, it's passing through it, looks like 3. So that would have been x minus 3 in the parentheses. And again, it's just passing straight through. So I'm going to leave that as a 1 there. It is kind of looking like a W, so it is looking like one of these even degree functions. And it's opening up, so there should be a positive number out front, which means I'm just going to kind of leave it how it is. That's kind of assuming like there's a positive 1 out front. If you think about these being exponents of 1, if you add your exponents here, 2 plus 1 plus 1, that's 4. So that does make this an even degree function. Positive out front means this graph would open up. So the last example here, again, look at all your zeros and work your way over with an equation. So I'm going to start with my equation here at -2. So that must have meant in the parentheses it would have been an x plus 2. Now it is just touching it and bumping back off. So that would have been x plus 2 squared. Okay, I'm going to go over to the next 0, which is at negative 1. So that must have looked like x plus 1. It's just passing through, so that's to the first power. I'm going to leave my expression like that. And then over here at the next 0, which is 1, that would have been x minus 1 in the parentheses. And this is one where it's definitely passing through, but it's kind of like laying flat before passing through. So that must meant the expression here was to the third power. It's following that multiplicity of 3 pattern. So I'm looking at this graph, it is opening down, and if I add up the exponents, 2 plus 1 plus 3, that is 6. So that's an even degree function, but because it's opening down, the leading coefficient must have been a negative number. So you can just throw a negative out front. Okay, so in the worksheet that you do tomorrow, I believe the first page of it gives you a bunch of graphs, and I ask you to write me the equation in factored form. You do not multiply these out. All I want is this type of equation. Give me the zeros with the correct exponent, and if it needs a negative out front, you need to just put a negative out front. On the second part of the worksheet, I'm going to ask you, that you're going to do tomorrow, I'm going to ask you to graph. All right, so for number 4, I want you to sketch a graph of the polynomial with these multiplicities, and I also want you to write this equation in factored form. So first I'm going to start by writing out the equation. So these are all of your zeros, okay? So like if you have a 0 of negative 5, then that must have looked like an x plus 5 in parentheses. Its multiplicity was 2, so that gets squared. If you had a 0 of negative 1, then that must have looked like x plus 1 with a multiplicity of 1. I'm just going to leave that as 1. If you had a 0 of 2, that would look like x minus 2. This one had a multiplicity of 3. And your last 0, which is 4, that would have been x minus 4. And your multiplicity is 2. So I'm going to add an x to the second power. Okay, so that's factored form. Okay. The degree here, I'm going to put the 1 in there. If we add those up, 2 plus 1 plus 3 plus 2, that gives me a degree of 8. So this is an even function. And I actually didn't specify, but let's just assume the leading coefficient's positive. If I want it to be negative, I'll tell you, like on the worksheet. So here's how you're going to graph it. You are going to put a point at each x-intercept. So I have an x-intercept of negative 5, negative 1, 2, and 4. Because this is a degree 8, because it's even and the leading coefficient's positive, my graph has to start opening up and it has to end opening up. Even degree functions opening up, all right? And then as I approach each 0, I'm going to do what the multiplicity says. So remember, a multiplicity of 2 just touches it and bumps back up. And I'm going to head to my next 0. So at negative 1, it's a multiplicity of 1. So that's going to pass straight through it. As I approach 2, the multiplicity is 3. So it is going to pass through, but I'm going to lay flat, and then I'm going to make it come through. And at 4, x equals 4, it's a multiplicity of 2. So it's just going to touch it and bounce back off, and I'm going to connect it back up to the top there. Okay, so you go from left to right, right? Start it and stop it based on if it's an even or odd degree, leading coefficient positive or negative. Okay, connect from left to right, do what each multiplicity should do at the 0. And, at these little bumps here, I don't really care how high up or down you go. I'm looking at, did you start and stop the graph where you should? And at each 0, is it doing what the multiplicity said it should do? So what I want you to do is try number 5 on your own. And then what you can do is check my notes key under the notes folder to see if you graphed number 5 correctly. I'm going to put number 5 on Schoology with the correct notes. Actually, you know what? I'm not going to do that. Throw that in Desmos. Put it in Desmos and see if your graph matches the one on Desmos, okay? And when you're done,